Okay, so hello and welcome back. Now, what we're going to do is we're going to look at a quick mixed exercise of the things that we've already looked at over here. And so I'm going to ask you to do a few. Let's say I want you to do this one. Let's just select a red pen. I want you to do D over there. You can do B for me. You can also do F. Um, you can do that one over there as well. One over that one there. And then this one over here. Okay, and the rest you can also do as well. So there's 6 problems for you to try. I want you to press pause in the video and then you can continue thereafter. Okay, so now that you've done that, let's look at each of these. 9 to the minus 1 multiplied by 9. Okay, so let's look at that. 9 to the negative 1 multiplied by 9 to the negative 2. Again, we remember that this here is your base. Okay, that's my base. That's my base over there. And so is that over there. That's also my base. And when I look at the two bases, they are identical, they are the same, and I'm multiplying something, so I can use the law of exponents here, the first law. It's going to be keep the base and then add the exponents. It's negative 1 minus 2, or negative 1 plus negative 2, which gives me 9 to the minus 3. If I had to ask you to write that as a positive exponent, remember our rule, 9 to the negative 3 is exactly the same as 9 over 1. That's a 9 to the power of negative 3. 9 over 1 to the power of negative 3. And all you need to do is you just need to tip this, flip this on the inside, it's 1 over 9, right? And change this negative 3 to positive 3. And remember that simplifies to 1 to the power of 3 over 9 to the power of 3. And this thing over here is just simply 1 over 9 to the 3. Okay, and as soon as, with some practice, you'll be able to go right from there all the way to that over there. Okay, that's the one. Let's look at the next one. Oops. Okay, so B is 2 to the negative 1. Another simple one. 5 to the 2 divided by 5 to the negative 2. Let's bring that up. 5 to the power of 2 divided by 5 to the negative 2. And then the other one was 2 to the negative 1. So let's solve the 2 to the negative 1. Well, that's exactly the same as 2 over 1 to the power of negative 1, which I can flip this on the inside as 1 over 2, and I just make that positive. And using the other law, when you have a fraction that is raised to a power, you raise the top to the power and you raise the bottom to that same power, and then we get that. That is using the law that says a to the negative 1 is equal to 1 over a. That's my law. Always bring it back to your definitions, your laws, and so forth. Now what about this thing over here? Let's look at that. That's 5 to the power of 2 divided by 5 to the negative 2. Again, the bases are the same, right? So I keep the base and I say it's equal to 5 to the power of 2 minus, but the exponent itself is minus 2. And then 2 minus minus 2, the answer is going to be 5 to the power of 2 plus 2. Because when I multiply that there, I get 2 plus 2, and that's going to give me 5 to the power of 4. Okay, similarly, this is exactly 5 to the power of 2 divided by 5 to the power of negative 2. And when I bring this up to the top, I'm going to change it from a negative to a positive exponent, which is going to be 5 to the 2 multiplied by 5 to the positive 2 over 1 now, which just becomes 5 to the power of 4. So using the law, right? Using the law, and also using just a little bit of messing around and moving exponents or variables that are at the bottom to the top, we can also achieve the same result. Okay, are we ready for the next one? So we've done that, we've done that, we've done that, and we are now looking at the following. 1 over 1 over 10 to the negative 1. 1 over 10 to the negative 1. Now for this one, we're going to have to do things a little bit differently. We might have to work a bit backwards. 1 over 10 to the negative 1. Do you remember that any 1 to the power of anything is just itself, right? That's one of the other rules. Anything to the power of 1 is itself, and also 1 to the power of a million. 1 times 1 times 1 times 1 times 1 times 1, and on and on and on, will always be 1, right? Right. So what I'm going to do is I'm going to take this and make this 1 over 10, and I'm going to raise that fraction to the negative 10. Okay? Are you all with me? Sorry, not negative 10, but negative 1. 1 over 10 to the negative 1. Because remember, this here, or let's break it down further, let's say that is actually 1 to the negative 1 over 10 to the negative 1. And then if I use the law that says a to the power of n over b to the power of n is equal to a over b to the power of n. If I look carefully at this, I'm now working from this thing here to that thing. And this law goes both ways, right? So what I want over here is I'm going to say, well, okay, that can be just 1 over 10 to the power of negative 1. And if I flip this, all I need to do now is I need to make it positive. I can make it positive, and I can just do a simple flip, and I can say, well, okay, make that 10 over 1 to the power of positive 1. And if you want to use a shortcut, think about it as taking this thing to the top, right, and bringing that thing to the bottom. So if I take that thing to the top, the exponent there becomes 10 to the power of 1 over 1 to the power of negative 1. And that just there is 10. And 1 to any power is just 1. So that simplifies to 10. Okay, so that above is true, and so is the below. And if there's something I want to say with this is, remember, 1 to the power of 10 is 1. 1 to the power of 100 is 1. 1 to the power of 20 is 1. 1 to the power of cow, oh mother of cow, is also 1. There we go. Let's look at the next question. 2 plus 2 plus 2 to the negative 1. Oops, let's go one back. 2 plus 2 plus 2 to the minus 1. 2 plus 2 to the minus 1, well, there's no law of exponents here. We simply have to work it out. That's just 2. And this thing over here, remember, 2 over 1 to the negative 1. I'm going to simplify that as 2. Flip this. Just flip it and make the exponent positive. And then I get the following. I get 2.5. And there's my solution. Okay, one more. 3 to the negative 1 raised to the negative 3. 3 to the negative 1 raised to the negative 3. Well, applying the law that says a to the power of n multiplied by, raised to the power of m, all I need to do is I just say a n times m. In this particular case, it's going to be 3 multiplied to the power of negative 1 multiplied by negative 3. And what does that give me as a solution? It's going to give me 3 positive, negative times negative becomes positive, and then 1 times 3 becomes 3. So it's 3 to the power of positive 3, and that's my solution. Okay, so what I'm going to leave you with now is to try a bit more trickier ones, which I believe you can do, and then we'll also post the solutions. Okay. Press pause in the video now and do this entire left-hand column for me. A, D, G, J, M, P. And then press pause. Okay, so let's start over here. Solutions, I'm going to give it to you straight away. This here is just, the only thing we want here is we want positive exponents, right? So we don't want to see the negative 1 there anymore. Okay, so x to the power of negative 1, straight from the definition, the solution is 1 over x. This thing over here, this thing breaks up into a multiplied by 1 over b, because b to the negative 1 is just 1 over b, right? And then if you multiply that, remember this is a over 1 multiplied by 1 over b, it's going to just give me a solution of a over b. And there we have our positive exponents. Okay, this one over here, I have to raise each of the bases. That 1 to the negative 2, and that one to the negative 2. So it's going to be 2 to the negative 2 multiplied by x to the negative 2. And well, you don't want negative exponents, right? So what you want to do is you want to give me a solution that says something like, okay, sorry, I'm working a little bit messy here, and that's going to be just 1 over 2 to the 2 multiplied by 1 over x to the 2, which simplifies to 1 multiply the numerators by and the denominators. That's going to give me 4x squared. Okay, another way of looking at it is doing our flip rule. Remember, treat this entire thing as the base, right? If I treat the entire thing as the base, that is 2x over 1 to the power of negative 2. And that simplifies into the following. It simplifies into saying, okay, all I need to do is I just need to put it 1 over 2x to the power of positive 2. Then raise the top to the 2 and the bottom 2x to the 2. And that's going to give me 1 over 4, 2 to the 2, x to the 2, which gives me 1 over 4x squared. Look at both ways, right? With some practice, remember I said you'd be able to go straight from there right down to the bottom without all these intermediate steps. For now, I'm just showing you that it's true. Okay, this one over here, what is that going to give us? Well, again, that is the same as 2 over 1 to the negative 3. Make the exponent positive and flip the inside, which is going to give you 1 over 2 to the 3. If you simplify that, it's going to be 1 over 2 to the 3, which is 1 over 8. Okay, and then finally, this one we can just take that to the top and bring this one to the bottom. So if I take b negative to the 4, it's going to become b to the positive 4 over a to the negative 3. A to the positive 3. And then finally, the last one over here is going to be take each of the fractions and raise them. Let's do the inside first. If I take the inside, I'm going to make it 1 over b times a squared. And I want you to raise the top to that and also the bottom, and you should get a result of 1 over a squared b squared. Okay, you can also think about why it is that I turn them around and whether that is acceptable. Okay, all of the best.